Skeletal primitives are very popular in animation and commercials. As soon as you see dancing shampoo, it is a skeletal primitive. Another famous example is a liquid robot from the Terminator 2 movie. These are supported HyperFun primitives and operations. Last time we discussed algebraic primitives, and this theme is devoted to skeletal objects and convolution objects. In 1982, Jim Blin proposed an idea of modeling implicit surfaces or isosurfaces as a side effect of visualizing scalar fields. Imagine a point in space as a source of some scalar field, for example temperature. In the blobby model proposed by Blin, it was an electron density field. The surface of the equal field value for the given threshold is a sphere as shown in the image. Such a point is called a field source or a skeleton point. There are several skeletal model elements which will be illustrated later. Skeleton can include points, lines, and other skeletal elements. Scalar field with an individual skeleton element as a source. Global field is an algebraic sum of individual fields. Level or threshold of the field value defines the isosurface of interest. When we put several field sources in space, the surfaces of the constant field value become smoothly blended spheres, as is shown in two-dimensional example, left image, and in three-dimensional example, right image. The definition of the skeletal implicit surface includes the global scalar field f of p, which is an algebraic sum of individual scalar fields depending on the distance to a skeletal element, where n is the number of skeletal elements, t is the level value we select for the global field. Depending on the type of the individual field, there are blobby model, metaballs, and soft objects. Jim Blin in his blobby model used the shown formula with the exponential function for the scalar field, where r is the distance from the given point to the skeletal point. Pay attention to coefficients a and b, which will appear as parameters of the library primitive. The plot of such scalar field against the distance to the source point is shown here. Distance 0 means the skeleton point itself. The field is maximal at this point. Then field is decreasing with the distance from the skeleton point. The problem with this function is that this field never becomes 0. It means that each skeleton point has global influence to the shape at any point in space. This property makes it hard to control the overall shape interactively. Local influence of skeletal elements was introduced in metaballs and soft objects. HyperFun supports all three major models of skeletal surfaces, although sometimes they produce similar results. Blobby model has global influence of each skeletal point. Metaballs have local influence of each point and flexible local control of the shape. Soft objects also have local influence but more limited control of the shape. Library primitive blobby object has the following format, where x is a given point coordinates for function evaluation. x0, y0, and z0 are arrays of blob skeletal points. P is an array of exponent coefficients for each blob. Higher pi means more narrow peak and smaller i's blob. B is an array of blob weights. Smaller bi means smaller i's blob. T is the threshold value for entire model. Smaller t means expanded surface. Bigger T means entire contracted surface. In this blobby model with 6 skeletal points, we see that first of all necessary array are declared. Then values are assigned to them, and the library primitive is called blob. The library primitive format for metaballs is present here. The name of function hf metaball, where x given point coordinates for the function evaluation. x0, y0, and z0 arrays of blob centers. B array of metaballs weights. Smaller bi's means smaller i's blob. D array of d radii of influence of each metaball. Higher d-ith means bigger ith metabole. T threshold value for the entire model. Smaller t means expanded surface. Bigger T means entire contracted surface. Metaboles with 6 skeletal points is present on the slide by the following HyperFun code using library primitive hfmetabole. Library primitive soft object is given here in the following format, where parameters are x is given point coordinates for the function evaluation, x0, y0, z0 are arrays of blob centers. D is array of d radii of influence. Higher di means bigger ith component. T is threshold value for the entire model. Smaller t means expanded surface. Bigger T means entire contracted surface. This is a model of a soft object with 9 skeletal points using library primitive hfsoft. Note that it has only skeletal points and one parameter array of radii of influence as input.